He's ready for me to talk. So last year, we didn't give you equations with a root 3 because that would have scared you and you would have cried. But now, root 3 should kind of feel familiar. Where have we seen root 3 before? Tan is root 3, and then what about cos? Root 3 on 2. So that number is kind of familiar to us now that we've done the unit circle. So we're not going to cry. It's not going to freak us out. It's just a number. The very first thing we did last year, and the first thing we do this, is I need to get this sine theta by itself. I need to pick off all the other numbers. Again, don't copy, just watch me. I'm going to redo it for you. So I want to get rid of that 2. It's a coefficient, so that's a multiplication. So what's the opposite of multiplying something by 2? I'm going to divide it. So I'm going to take it over to the other side and say sine theta equals root 3 on 2. And that should look really familiar to us. That should make us feel a little happy. You're like, I know root 3 on 2. Well, last year we used our calculator to find reference angle. Now, because of the unit circle, we don't need to. Which of the 3 families has a sine value of root 3 on 2? You have 3 choices, pi on 3, pi on 4, pi on 6. This is asking what family has a y-coordinate of root 3 on 2. So what I do is I go, well, if this is root 3 on 2, because that's the y, which is the sine, what has to be first? 1/2. And if it's 1/2, it's got to be pi on 3. So we know that the reference angle, which is the same as the family, is pi on 3. Okay? That's what we did with the calculator last year. It's just, no, we don't need calculator now. We are that smart. But now I need to worry about the quadrants. So I go back up here and I say, okay, sine positive. Sine positive. Which quadrants? So theta in quadrant 1 is pi on 2, or pi on 3, sorry. What's it in quadrant 2? So what's the little trick for the numerator in quadrant 2? 2 pi on 3. Done. That's the end of the question. No calculator, all with unit circle. Don't you feel a little smart? Like, this is impressive stuff. This is really impressive stuff. Just going to go over the method box. Everything I just said is in there. So step 1, you're going to isolate the trig function. If it's quadratic, who remembers quadratics from last year? Unit 3, Unit 4, Unit 5, Unit 6, that was it. It's in everything. And over and over and over we said, how many ways are there to solve a quadratic? What are the 4 ways to solve a quadratic? Yes. Yes. Difference of squares. Yes. Yes. We're going to probably factor. Yes, sir.
There's also a fifth that you didn't.
I know, but they don't know it all yet, so we're just keeping that secret for a second. Yeah.
The fifth I was thinking of was the graph.
Oh, you're right, but we're just not, you're like a little bit ahead of me there. Just hang on to that thought. So if it's quadratic, which if you looked on some of the examples, they look scary because they're squares, we'll get there. Number 2 is you state the reference angle. That's the same as the family, and then the quadrants. Use the unit circle first. If you can't, that's a calculator question, and I'll show you what that looks like in a second. Then we give the answers in those quadrants. Then we check the interval and cross off any answers that don't apply. I'll talk about that in a second. And then if there's no interval, we give the general solution. Highlight or circle or underline the general solution. Who remembers it from yesterday? Plus 2 pi k. K, though everyone gets happy now. K is an element of? And I'll explain what that means when we get down there. Okay, now you do with me example number 1. 2 sine theta equals the square root of 3. 0 less than equal to theta less than equal to 2 pi. Step number 1, isolate the trig function. If you're a visual person, sometimes highlighting it tells you what you need to take away. So the sine theta is what I need left. It means the 2 needs to go. What's the opposite divide, or what's the opposite of timesing something by 2? So divide each side by 2. Then we state what's called the reference angle. And that just comes from asking yourself which of the families has a sine value of pi on 2. So you don't need to write this down, but in your head you're going to picture the sine value, which is the second. The second tells you the x, which is the other one. The X tells you the family, which one has a link to 1 on 2, 3. So we call it the reference angle is pi on 3. Yes, sir?
I prefer to think in degrees 60.
Yes, but we're not going to answer this question in degrees because the interval is given in rads. So if it's in rads, we answer in rads. Yeah, but you were so familiar with degrees. Imagine if we started throwing rads in last year. That would have been a lot. So we didn't. We were like, let's hold that back. Let's do that in grade 12.
Why don't we just stick with degrees then?
Because rads is better. It's more exact. We like
This
rads.
is better. They're almost always his whole number.
This is a philosophical debate. So now we grab the cast rule and we look, sign is positive. And I'm just going to put a red plus sign just to tell you later when you look back what we were thinking here. Sign is positive, so you picture the little cast rule in your head, which is always up there, the first blue sheet by the one that's falling down. So it's up there. You don't need to know it's there.
What's on the falling down one?
It's the one we're going to use tomorrow.
Oh, that's why it's falling down.
It's just excited about tomorrow, that's all. What quadrants is sign positive? We said quadrant 1 and quadrant 2. And so now we state the final answers. What is the pi on 3 family in quadrant 1? It's itself pi on 3. What's the pi on 3 family in quadrant 2? 2 pi on 3. This is why we memorized all the radians and all the quadrants. It's for this step right here. Now step 4, just like last year in grade 11, is we go back and we look up here, because there's always this interval that will tell us what quadrants we're allowed to use. What is the notation less than equal to theta, less than equal to mean in English? It means between. So this is saying our answers can be between 0 and 2 pi. So for the picture people, that's saying it can be from 0 all the way to 2 pi. That's saying you can have all 4 quadrants. If you scanned on the questions, those numbers are going to change periodically. Why? Because the question felt like it. Are these both valid answers? Are they both between 0 and 2 pi? Yes, we're good to go. Here are our answers. The last step is if there's nothing given here. So this was actually the last example that we didn't quite finish yesterday, is there was no interval. If no interval is given, what it means is you give the general solution. So if this was blank, I would have added plus 2 pi k k e z. But it's not blank, so I didn't add it. That's it. Same 5 steps every single time. No exceptions. They're never, ever going to change. Yes, sir?
If there is no interval, does that mean we could give the general solution in degrees if you wish?
Correct. Yeah, well, you're like ahead of me when we talked about number 7. I will say that. You can give it whichever way you want. Okay, let's do some more. Two cos theta minus root 2 equals 0. 0 to 3 pi on 2. So again, we didn't give you really equations last year with root 2 because it was such a weird number for you to see. Now that number should kind of make sense. Where have we seen a root 2 before? Root 2 over 2, so it's a common unit circle value. Yes, sir?
Does that say 3 pi over theta?
Oh, it's a 2. It was just kind of a sloppy, messy 2. The same one that's in the question. Step number 1, I want cos theta by itself. So again, highlighting just helps you remember what needs to go away here. I need to get rid of this plus root 2 first. What's the opposite of subtracting root 2? Adding root 2. Now I'm going to get rid of the coefficient of 2. What's the opposite of multiplying something by 2? Dividing by 2. That is step 1, isolate the trig function. Get the trig function by itself, get all the other numbers over to the other side. Step number 2 is the reference angle. This question is asking you is which of the 3 families has a cos value of root 2 on 2? Which of the 3 families has an x value of root 2 on 2?
The same one that also has a y value.
Yes, which is?
Pi over 4, or if it was in degrees, 2. He is 45.
Yes. Just think, like 6 days ago, you had no idea about the unit circle. Look how much you have learned in less than a week. Step number 3 is we go back up to the step above where we isolated the trig function and we think about the cast rule. Cos positive. Tell me the quadrants where cos is positive.
1 and 4. But hold up.
No, just don't yet. No holding up yet. What is the pi on 4 family in quadrant 1? I think Andrew is just as excited about these as I am. What is the pi on 4 family in quadrant 4? So you're just thinking of how do we get that numerator in quadrant 4? Fourth step is we look back up to the interval and we say, are these both possible answers? So what does this 0, 3 pi on 2 with these squared brackets mean? 0 all the way to 3 pi on 2. So what quadrant is out? Which one can we not have because of the interval? All we do is cross it out. You can't not write it, and I understand that was a double negative. You can't not write it. If you don't have it, I don't know, did you know it was there and know to cross it off, or did you not understand the casserole and know it was there at all? You have to write it. You show me that you understand the interval just by crossing it off. Again, if you just give me pi on 4, I don't know, did you know there was a quadrant 4 answer and because of this you didn't write it, or did you just not have a clue there was a quadrant 4 answer? This is how we present. You cross it off.
But that's a waste of pencil lead.
Sometimes we just need to kill some trees and waste some lead. Just the way it is. Just the way it is. Do we need to do step number 5? So do we need that general solution? No. When do we write the general solution? Final answer, pi on 4. Look at all that, no calculator. That's how smart you guys are.
That's how smart we like make to think we are.
No, it's true. You realize that only 20% of the population takes pre-cal, so only 20% of the population can do this. And anybody really over the age of 20 is completely forgotten. So you are like a tiny little minority of the population that can do this stuff. Smart.
1%. Close enough.
Left brains will love that it's the same steps every single time. I promise you there are no exceptions. They're not going to change. The first is isolate the trig function. So again, for visual people, highlighting that just helps you remember what needs to go. If you don't have to highlight it, don't. It's just a trick. So this -1 needs to go to the other side. What's the opposite of subtracting 1? The negative imaginary 1 in front of the tan needs to go. What's the opposite of multiplying something by -1?
Dividing by negative.
So we're down to tan x equals 1. That is step number 1, isolate the trig function. Step number 2 is the reference angle or the family. This is asking you what what family has a tan value of 1. This is why we memorize the 7 values of tan, so we don't have to go through all the work. We know because we've memorized what family has a tan value of 1.
45.
I'm going to go pi on 4. Hang on with me here. Just hang on with me here. The quadrants come from this step, and it's the casserole, where is tan negative. What is the pi on 4 family in quadrant 2? I heard 3 pi on 4, confirmation. Sure is not really confirmation. It's kind of just humoring me. Thank you. And what is the pi on 4 family in quadrant 4? Now do you get why I made you memorize those little rules? That is step 3. Step 4 is we check all the way back up here. But wait, it's in degrees. So now we just convert. If you wanted to give 45 up here, there's nothing wrong with that. It's just harder to know the the degrees down here because we didn't memorize rules. However your brain works. If you want to give it here, great. If you want to give it at the end, great. Middle of the quadrant in quadrant 2, what's halfway? Well, you can do 3 times 180 divided by 4. Oh, I heard someone say it. And in quadrant 4, the middle of the quadrant is? And we just check again, are those between 0 and 360? Yes. Do I need to add the general solution? Why not? Make yourself a note that the answer matches the interval. So if the interval is in rads, you give rads. If the interval is in degrees, you give degrees. That's a 1 mark off if you give it in the wrong system. Okay, so your answers match the interval. Another note for this question is it has x, not theta. You cannot switch your variable unless it's somewhere in the question you decide to put let x equal theta. Then you can throw theta in. But what's going to happen is your brain is so used to writing theta, it's somewhere in the middle you're going to switch it. That's a half mark off. So you need to make yourself a note, keep the variable. Just keep it. If it's in x, you keep in x. If it's in theta, you keep in theta. So keep your variable. Show me your thumb so far. I'm liking these. I'm getting them. I'm kind of getting them. I hate them.
Which one was hate them?
Good. Hate them. Hate them. They did nothing to you.
They will do on the prevention of that.
Ha. I'll teach you. I'll train you well. WTH. What is going on? There's stuff all over the place. Quadratic. It's quadratic. It's quadratic. Who doesn't love factoring? Remember factoring in grade 10, we were like, this is really important, you need to know it. And then grade 11, we were like, in 3 units, this is really important, you need to know it. It's going to come back in 4 units this year. If you still cannot factor, come and see me. I can help. You cannot get through this course still pretending that you can factor if you can't. Okay? Grab a different color pen. I don't care what color. And I'm just coming off to the right-hand side. So that's usually when it's not really part of the question. I just want you to do something. That is a grade 10 question. Factor it. I cannot reteach you right now how to factor. If I could teach you in 5 minutes, we wouldn't have spent a whole unit on it in grade 10, and we wouldn't have practiced it for 3 units in grade 11. All I'm going to do is give the answer. If you're like, where did that come from? You need to come and see me. But I cannot stop and show you how to factor now, because again, we've been doing that since grade 10. You should have 2x plus 1, x plus 1.
Does that say 2x plus x?
Oh, it does, but I meant to say 1. Again, if you're like, what? Come and see me, but I can't stop because that took us a whole unit in grade 10 to get you to this point. So if with the x, it's 2x plus 1 and x plus 1, what do you think is going to happen over here? 2 sine theta plus 1 and sine theta plus 1. So if your brain is like, I'm not doing sines and factoring, that's crazy talk, then do it with x off to the side. There's nothing wrong with that. Your brain is used to seeing x. I'd say 95% of questions you've factored since grade 9 have had x in them. So if your brain is used to this, then do it. Then just come over here and put the factored form down. What did we do with quadratics last year after we factored? What was the next step? Split them and solve. I always put a squiggly line. I don't know why. It's just my brain. I call it Mr. Squiggs. You'll meet him this year, Mr. Squiggs. So we take the left-hand side and we equate it to 0. And we take the right-hand side and equate him to 0. Again, we solved a bajillion quadratics last year, so this should look really familiar. What this is just 2 little questions. I'm just going to ignore the right-hand side for now, and I'm just going to look at this side. Isolate the trig function. So get that sine x all by itself. I heard an offer of a half. Correction of a negative a half. That sounds confirmed. Reference angle. What family has a sine value of a half? What family has a sine value of a half? Okay, I heard pi on 3 and I heard pi on 6. So in your head, you're picturing the second coordinate being pi on, or 1/2. That means the first one is root 3 on 2. Root 3 on 2 links to pi on 6. Quadrants. Sine negative. I heard 3 and 4 confirm. The pi on 6 family in quadrant 3. Seven pi on 6. And the pi on 6 family in quadrant 4. Okay, now I'm just going to ignore the left and let's go to the right. Repeat the exact same steps. Isolate the trig function. I heard someone say -1. That's not a family. Those are axes values. So you need to think, where is the y coordinate on the circle -1? So you're looking for the y coordinate -1. What does theta have to be? 3 pi on 2. How do you know that's an axes value and not a family value? Because it's sine, more specific. The 3 family values are a half, root 3 on 2, and root 2 on 2. If it's zeros or 1, it's an axis value. Okay, now we just need to check the interval like we did before. What does this interval mean? What is it telling you? Theta between 0 and 2 pi. Are these between 0 and 2 pi? Is this between 0 and 2 pi? Now, you don't have to, but on the exam, it's really, really handy if you list them together from smallest to largest. And so Q3 is going to come first. The axis in between is going to be next. And Q4 is going to be last. They'll still give you full marks if you don't do that. It's just really easy for your marker if you list them in order and then box them and show them somewhere, because there's a lot on that page. And if you make a mistake, they're trying to find where your answers are. So just list them in order. That wasn't so bad, was it?
Of course.
Was it?
Of course.
Yay!
It was.
Thank you for your support.
Always need someone negative in the room.
And it's usually the grumpy guy in the back corner. It usually is.
Oh, it's -0.
Oh, he's -0. That's right. Can I flip? I just feel like there's people still writing.
Hey, if you think I'm Mr. Darkside, you should meet my brother.
Ooh. Not sure I can handle 2 of you.
Don't worry, he doesn't believe -0 exists. What's wrong with that guy?
What? Secant? Where did you come from? Secant sometimes just crops up in there. So this is a little scary because there's secant, there's a squared. So let's just ignore secant for now. And over here, if I just gave you x equal to x and I said factor it, what would you do? Maybe you'd cry first, but then you'd wipe those tears. What would you do? Take a slip of your Slurpee and then... Yeah, to factor, we need everything onto one side. So you're probably going to bring something over. It's probably going to be the x. Now what? Well, you'd square root it, but then you're going to have x equals square root of x. It's not going to get you anywhere. It's going to be even nastier. For some reason, this kind of factoring throws people off, and it's the very first kind you learned. It's the easiest kind of factoring. It rhymes with an actor. It's a common factor question. That's all it is what is the same term in each of those terms? What do you see the same between x squared and x? There's an x, so I'm going to pull an x out front. Oh, factor from x, so x squared divided by x. And x divided by x. So it's just a common factor question. Okay, let's bring it over here. If x squared equals x factors into this, what is the secant dude going to factor into? What's going to happen over here? So just follow the pattern. So we're going to have a secant, then a secant, minus 1. If you can factor with the secants, great. If your brain needs x, great. Do it whatever way works for you. I don't like factoring with the secant. My brain likes x. I like to see this over here. But if your brain can do it, great. What do we do after we factor? Split and solve. So secant theta equals 0, or secant theta minus 1 equals 0. Covering the right, I'm just going to look at the left. What do I do with secant? You're going to turn it to its friend, and secant is dating cos. So I'm going to throw in 1 over cos. Why did I put 1 over cos? Why did I do that? Because it's a reciprocal function, so secant equals 1 over cos. Okay, how do I get rid of a division by cos? What's the opposite of dividing the left-hand side by cos? Multiply each side by cos. So times cos, times cos. So I get 1 equals 0. WTH. What does that mean, 1 equals 0? It just means there's no solution on this side. It's done. We can't solve it. It's impossible to have 1 equal to 0. It's done. Finished. That side is over. Okay, let's go to the other side. What do you want to do here? If you're never sure, go back to your method. Go back to step number 1. What is step number 1? Isolate the trig function, so get secant by itself. That I know you know how to do. How do you get rid of a minus 1? I don't want secant in there. I don't like him. He's not what I memorized on the circle. What do I want to replace him with? 1 over cos. Okay, how do you get rid of a division by cos? We times each side by cos. So on the left, it cancels and leaves me 1. On the right, better than last time, cos times 1 is cos. Is that a family or is it an axis value? It's an axis value. So again, picture right-hand side of the circle, 1 unit to the right. 0 or, do you have to put both? Yes, you do, and I'll tell you why in a second. We're only on step 3, by the way. What was step 4? Well, that's just going back and checking your interval. What does it mean, 0 to pi? It means anything bigger than pi, out. So what do I need to cross out? That's why you need to put both. Because if you just had 2 pi and you crossed it out, you're saying there's no answer, and there is an answer, it's 0. General solution or no general solution, and how do we know? No general solution, why? So all of this, you won't appreciate this, but as a mathematician, all of this equals 0. That just makes us really, really happy. All of that crap up there, the squared, the secant, everything, the answer is 0.
You gave us a really hard-looking question.
I know, and it equals 0.
0?
It makes us happy, it really does. This would be 4 marker.
For what, and what?
You would get a mark for the factoring. You would get a mark for getting down that there's no solution on the left. You would get the 3rd mark for getting down to 0 and 2 pi. The 4th mark would be for crossing out the 2 pi. So 1 for factoring, 1 over here, 1 over here, 1 for crossing it out.
Mark just for crossing out a number.
Because it means that you understand what the interval's telling you. Ooh, 6 sine squared plus sine x minus 1 equals 0. Lots of cool stuff going on here. This is a hard one. Not going to lie, this is a hard question. Okay, so you're not going to be expected to turn around tomorrow and know how to do this by yourselves. You're working up to this. I'm just showing you examples that increase in difficulty. First thing I do is I forget about the signs, and over here I just look at with x's because my brain is used to factoring in x's. So 6x squared plus x minus 1. Go ahead and factor that. That's a grade 10 question. Ms. Thompson, how did you do that so fast? Because I have been factoring for like 35 years. That's how I can do it so fast. You're probably going to need to show some work or do more thought process in your head. This is called product sum factoring. So if you did it the way we did it last year, that's where you take the first times the last, then the middle, remember, kind of all that. If you're like, what is she talking about? Come and see me. I will show you. But you should be able to, on your own, get down to 3x minus 1 and 2x plus 1. Okay, so let's bring it back over here. Instead of x's, what are we going to put in its place? Sines. So I've got 3 sine x minus 1 and 2 sine x plus 1. If your brain did not need these x's, that's fine. If you can jump straight from this to this, great. What do we do after factoring? Split and solve. So 3 sine x minus 1 equals 0. And 2 sine x plus 1 equals 0. Isolate the trig function. Get the sine x by itself. Confirm a third. What family has a sine value of 1/3? None of them. Okay, abort plan. Let's go the other side. So when you're stuck with something you don't know, leave it. Come back to it. That's a really good exam strategy. It helps you not spending 25 minutes staring at one question. Leave it and come back to it. Okay, isolate the trig function. Get the sine x by itself. Had an offer of -1/2. Okay, family. What family has a sine value of 1/2? I heard and confirmed pi on 6. What quadrants have a negative sine value? Four and 3, 3 and 4.
What is dividing by pi on 6? The x?
XR, that's a little subscript r, which means reference angle.
Oh,
Could be a theta r or XR. It's a little tiny r.
okay.
Okay, what is the pi on 6 family in quadrant 3?
7 pi over 6.
And what is the the pi on 6 family in quadrant 4? Okay, now I got to go back to this left side. Which family has a sine value of 1/3? 1/3. None of them. Well, we only memorize 3 families. We only memorize 30 degrees, 45 degrees, 60 degrees. There's other degrees in the circle. There's 50 degrees. There's 62 degrees. There's 13 degrees. There's lots of other degrees. We only chose to memorize 3 because they're the most common angles that come up in architecture and engineering. You don't usually engineer something with a degree of 54. It's not a great value. You tend to do things with 30 and 60s and 45s. This is a calculator question. This is the only time you're allowed to grab your calculator if it is not a unit circle number that we memorized. Okay, so make a note. This now becomes calc. And I lost my calculator. So first thing you do in your calc, just like last time, is you check your mode. How do we know what mode we want to be in? How do we know it's radians? What tells us in all this mess that we want to be in radians? The pi's up here tell us rads. So if you're not in rads, get into rads. How do I type this into my calc? Sine 1 divided by 3. Oh, bracket. Oh, 2 brackets, okay. I don't know. It's old. I'm waiting for someone to fix the mistake. When do you inverse and when do you not? This is always a big trig question. Well, let's just go back to what do you know about solving equations. Solving equations is always doing the opposite of what you know. If we're adding 1, what do? We subtract 1 to cancel it. If we're multiplying by 4, we divide by 4. If we're squaring something, we square root something. What's the opposite of sine? How do we cancel a sine? The only thing that can cancel a sine is an inverse sine. So mathematically what we're doing is we're actually putting inverse sine on both sides. And these cancel and they leave you x. That's why you're inverse signing on your calculator. It's just to cancel a sign. How do I inverse sine on a calculator? Second function, sine 1/3.
You also know that there's like degrees you would always.
You get a funky answer if you did it with degrees. You're like, whoa, what is this? Let's go to 3 decimal places because the question doesn't say, so hey, why not? 0 point.
3404.
These are the exact same step. One we did with our brains because we're that smart. One we did with the calculator. Now we need this equivalent step. Sine is positive. Quadrants where sine is positive. How do we get the answer in quadrant 1? It's just what it is. It's what the calculator can give you. How do we get it in Q2? So if you forgot the little rules, this is theta r or xr. This was pi minus xr. Pi plus xr. 2 pi. Take a look at this and think about the numerators of the family. What was the numerator in quadrant 2 for any family? What's the numerator in quadrant 2? N minus? Oh, and what was it in quadrant 3? N plus 1. And then in quadrant 4? That's where it's all coming from. Okay, answer in quadrant 2 with your calculator, pi minus 0.340.
2.802.
Can we get confirmation for 2.802? Going once? Going twice? No confirmation? Can we get another answer?
It would be pi.
Minus 0.340. That sounds confirmed now? It's always so funny to me that this becomes the hardest part of these questions where it's what you did last year. And last year you're like, yes, calculator! And now we take it away and you're like, what? I don't know how to use my calculator. It's because you're so smart you can do all this in your head. But wait, we're not done. That's only step 3. What is step number 4? What is going on? What is this? What is this? So we have to do some kind of opposite way. When you see this interval, Negative pi less than equal to x less than pi. It means that any answers you had in Q3 and Q4 are out, and their negative coterminal answers are in. What? Things we already learned. I'm going to repeat that. When you see this interval, it means quadrant 3 and 4 are out. Their negative coterminal answers are in. So anything you have in 3 and 4, you have to state the negative coterminal. That's what this is telling you. Take the negative coterminal of anything in 3 and 4. Oh, you know. Was this in Q3 or 4? So it's good. Was this in Q3 or 4? It's good. Was this in Q3 or 4? It's out. We need to give its negative coterminal. Okay, we did this on a quiz yesterday. How do we do a negative coterminal? Minus 2 pi. I didn't. No, it's not there. You just were imagining it. We're good with that? A little painful there. Is our last answer in quadrant 4? What does that mean because of this interval? Negative coterminal, so now I have 11. Now I have 11. Negative pi on 6. General solution, yes or no? No, why not? Crazy stuff at the beginning. That's as very hard as they're going to get. That's the hardest that they're going to get. Last one for me, and then you have some time to work. Tan squared minus 5 tan theta plus 4 equals 0. The little squared tells you it's quadratic. Quadratic means we probably have to factor. I like to factor with x. It would, but then you're doing extra work, and what do you do if it's a radical that you don't know? But yes, it's a great backup plan if you can't factor. But really, your chances of getting through pre-cal without knowing how to factor is so small.
I was saying safe.
Yeah, absolutely. It's a great backup plan.
I know the answer.
You're ahead of me already. Confirm x minus 4, x minus 1?
I wrote it as x minus 1, x minus 4. Does it really matter?
Nope. Is 3 times 4 the same thing as 4 times 3? Yep. Why?
Wouldn't that be positive?
I think you're having a brain fart. If I were to multiply this out, I'm going to get x squared minus 4x minus 1x plus 4. Okay, we're good? Okay, so come over here. What's this going to be with nasty tans in it?
Tan theta minus 1, tan theta minus
Sure,
4.
can switch them around. This is the sum in the middle, product sum.
Multiplication, I'm like, that's why I was.
This is a split and solve.
You can also like not plot in, if it was a larger algebraic question, you can not plot in the tan square. You can just get x at the very end and then put it in.
Yeah, absolutely. If you want to solve from here, x equals 4, x equals 1, and come back, absolutely. Absolutely. Again, I'm visual, so I like to block off half so I don't see it. Again, a really good technique if you find yourself in exam panic is just physically block off half the question because it stops your brain from panicking. Okay, isolate the trig function. Ooh, look at that. Reference angle, what's the family that has a tan value of 1? This is why we memorize the tan values. Quadrants, offer of 1 and 3. Where is that coming from? Why did we pick those? Because cast and tan is positive. Theta in those quadrants, so the pi and 4 family in quadrant 1. And then quadrant 3.
5 pi on 4.
How are we doing so far? Okay, this guy here. Family. So what's the family that has a tan value of 4? None that we memorize, because we only memorize 3. What does that tell you?
Alert, cal alert.
I enjoyed that calculator alert siren. What do we tell the calculator? In the middle, in the middle of the exam, that'd be awesome. Okay, what do we tell the calculator to do? How do we get them to give me the answer here? Inverse tan, 4, I'm not showing you, to 3 decimal places. That sounds confirmed. Quadrants.
1 and 3 again.
Theta in quadrant 1. Quadrant 3. I heard it, but I didn't really hear it. So pi plus. Okay, which would be? 4.467. Did I hear that correctly? Is everybody okay where those values are coming from? And this is where we always think we're done because it feels like we're done because we have an answer. That's only step 3. What is step 4?
Check to see if
Check the interval. Uh-oh. Can I have that siren? So if there's no interval, what, we're done? No, we jump to step 5. All I'm going to do is list them in a row. I don't really care the order here. You can also give them in smallest to largest. So if you want to put the Q1s together, then it doesn't matter. Just give me all 4 answers.
why did you say you prefer it like that?
Because it's easier for the exam markers.
Oh.
So if everyone does it the same way, it's just easier for us.
Oh, okay.
Plus
2
2 pi k bracket.
Hey, is that
Is there another plus sign in here? I've shown you easy questions, I've shown you hard questions, I've shown you calculator questions, I've shown you non-calculator questions. I've shown you with an interval, I've shown you without an interval. I've shown you in degrees, I've shown you without degrees and radians. I've shown you with secant and those reciprocal functions, I've shown you without. That's what we have done in the last 50 minutes. I've shown you every kind of example. You need to practice. Questions are there, or sorry, the page is there. The questions are on the calendar. This is the first time we're actually using the workbook, I think. Oh no, we did for some of the applications.